So still we have a standard normal distribution. Yep, mean was 0. See the z, right? Please read this problem carefully. Example 6.6. What do we need? Before, a z-score was given. Positive 1.23, negative 0.63, positive something. The z-score was given. But now, do we need a probability? Is it asking us to find a probability? No. Find a z-score. Just a second. I need a space. Yes, here. Before, we had a z-score. We took a probability. Where? From the z-table. But remember, always it is to the left, right? Yeah. But now we need the z-score from a probability. This way. How do you think? Where can we take the z-score from? From the z-table again. Yes. You know, it's not only this way, but also the reverse way. We can take the z-score from a given probability from the z-table. So let me go back to the example. Yep, here it is. Okay, let me keep it. Here was the probability, 0.04. Where it is? To the left. Can you see that? Let me make bigger. There is an area, 0.04, to its left. What does it mean? What do you expect? The z-score will be negative or positive. You know, the probability is 0.04 is to the left. It's to the left. Then, is this one is a 0.04 or this one is a 0.04? How do you think? Which one? You know, the example suggests us the probability is to the left, which was 0.04. Then do you expect the z-score must be negative or positive? How do you think? This one. I mean this one. Is it bigger than 50% or less than 50%? It must be bigger than 50%, right? So it is wrong. It is wrong. 0.04. 0.04. It is very small probability. So it's not there, but here. So we can expect negative z-score. So we have to go to the negative z-table, right? I gave you the two tables, but we have to go to the negative one. Where were the probabilities? Who are here? Who are they? They are the negative z-scores. You know, the probability cannot be negative, right? So here's the z-scores, and there's a second decimal of the z-scores. Then where was the probability? In the middle. So now we have to look for the probability, 0.04, in the middle. 0.04. Where is a 0.04? You know, here is a 0.004. It's much smaller than 0.04. Yes, here. I can see the two probabilities, 0.0392 and a little bit bigger than 0.04. It is a 0.0401. Probably between these two probabilities, between 0.0392 and 0.0401, there is the probability 0.04. But what do we need now? We need a z-score. So reverse way, we have to take the first decimal and the second decimals here. I'm sorry, let me count. It is the 1.0, 1, 2, 3, 4, 5, 6, and 7. So it must be negative 1.7 between negative 1.75 and negative 1.76. Because we had exactly a probability 0.04. But on the table, there is not exact probability 0.04. So roughly, we can take the two z-scores. It's between negative 1.7, 5, and 6. What should I do? We can take the average. So we can take one z-score, negative 1.75, and take the average, and the other one, 1.76. How can I do? Take the average, take the sum, divide by 2, please. So most of the time, we couldn't find the exact probability. So usually, we have two z-scores and take the average. So did you get negative 1.75 and 5? But in this case, 0.04 is closer to 0.0401. So simply you just take one z-score, negative 1.75. The either one will be good. Because now it's 0.04. It's almost the same as the 0.0401. The two probabilities. But I suggest to you, take the two z-scores and take the average. So the z-score will be negative 1.7, 5, and 5. So the z-score here, it must be negative 1.7, 5, and 5. Do you have an idea? Yeah, exactly reverse way, we can take the z-score. The next one, find the z-score again. Find the z-score again, but this notation means the subscription 0.025, it is the probability. It is the probability. To the left. Okay? So that is the probability to the left. So now again, go to the table. We have to look for the probability 0.025. So let me erase. Okay, let me erase them all. Now we are looking for another probability in the middle of the table, 0.025. Let me see. 0.025. 0.020. Can you find? I got it. 0.025 exactly. In this case, we don't have to take two z-scores. We have exact probability 0.025. What do we need? The z-score. So reverse way, we take this one. It is the last one. What do you expect? You know, here is a negative 2.0. Probably the lower one must be negative 1.9. 1.96. Negative 1.96. Less than a z-score, negative 1.9. There is a probability 0.025. So let me go back to the example. Okay, let me erase them. Now, let me make another standard normal distribution, mean 0. And I can say less than negative 1.96. There is the probability 0.025. You should understand where is the probability. Now the probability 0.025 is to the left. So we need the negative z-score because the 0.025 is less than 50%. How about the next one? The next one is here. To the left, there is a probability 0.05. It's the same idea. We have to go to the same z-table. And now look for another probability 0.05. Where is the 0.05? Between these two. One is 0.0495 and the other one is a 0.05 and 0.5. Where is the probability 0.05? Exactly in the middle. Exactly in the middle. So in this case, we have to take the two z-scores. I think it is a 0. It is a 0. And that is a 5, 6, and 7. 7 again. Negative 1.7, 4, and 5. Can you take the average? Negative 1.7, 4, and 5. Just like something wrong. I'm sorry. It is a 0. 1, 2, 3, 4, 5, and 6. Yes, I'm sorry. It is a 6. So between negative 1.64 and negative 1.65, how much will be the average? It will be negative 1.645. Negative 1.645. So the z-score will be negative, this one. For this one, it's a negative 1.645. Okay, it's good. Let me finish the last one. Here is a probability 0.95. Where? To the left, to the right? Where is the probability 0.95? Please read it. In the middle. What does it mean? Now we have a standard normal distribution, but in the middle, there is a probability, it's a 0.95. Then now, how much do you expect the probability to the left? Is it 0.05? How do you think? Here. How much was the whole area? Probability 1, the whole area. In the middle, there is 0.95. Then at the ends, the left end, right end, together, how much? The left one and the right one together must be 0.05. But I'm asking you, what is only the left one? I said the left one and the right one together is a 5%. Then how much will be only the left one? 0.025. Half of the 5%. Why? Because the normal distribution is symmetrical. So to the left is half of the 5%, the remaining probabilities. So the left one is a 0.025. Then how much will be the right one? The other one, 0.025. So when do we need the probability? When do we need the z-score there? We have to look for the probability 0.025. Can you remember how much was the z-score with the probability 0.025? We took it. It's before. Here, 0.025. The z-score was negative 1.96. You can try again on a z-table. Let's look for the probability 0.025 exactly. Then you can find the probability 0.0250 at negative 1.96. Okay? And also, we need the right one. We need the other z-score. But always the z-table had left tail probability. So how much will be the probability here then? How do you think? Here. How much was here then? Here. Here was 0.025. And also, how about here then, in the middle? There was 0.95. What I ask you, what will be the probability here? How much will be? Up to here, there is a probability 0.025. In the middle, 0.95 was given. When we add them all, just to the left, it's up to this z-score. There is a probability 0.975. So for this one, you have to look for the probability 0.975 on the page with the positive z-scores. How much do you expect? Absolutely, you have to look for the probability 0.975 to get the z-score here. But even you can expect how much will be. Any idea?
1.96.
Say again?
1.96.
Positive 1.96. How did you get positive 1.96?
The opposite of the other.
They are same. Why? Because the normal distribution is symmetrical.
Where did you get 0.975 though?
Here, 0.025. In the middle, 0.95. All together, just less than positive 1.96. There must be a probability 0.975. When you print out the z-table, please look for the probability 0.975. You will find a z-score positive 1.96. It must be same as this one. But this one was a negative 1.96, but now it must be positive 96. Why? Because the normal distribution is symmetrical. That's good?